Okay, for explaining the structure of complex compounds, Werner has proposed two postulates, mainly that important postulates of Werner. He has proposed two valencies of central metal atom or ion. What are those? One is primary valency and second one is secondary valency. So, what are the important characteristics related to primary valency? Primary valency is non-ionizable. Sorry, primary valency is ionizable. Sorry, ma. Primary valency is ionizable, but secondary valency is non-ionizable. Okay, primary valence is always outside the coordination sphere. Outside the coordination sphere, it refers to the oxidation state mainly. It refers to the oxidation state. It is satisfied by only negative ions. The primary valence is satisfied by only negative ions, and primary valence is variable. Primary valence is variable. Does not explain the geometry of the complex compounds. Does not explain the geometry of the complex compounds. So while drawing the structure of complex compounds, primary valence is represented by dotted lines. Primary valence is represented by dotted lines. Now come to that. What are the important properties of secondary valence and what it explains? Secondary valence is non-ionizable. Secondary valence is non-ionizable because the secondary valence is present in the coordination sphere. That's why it is non-ionizable, and it refers to the coordination number of the complex compound or coordination number of the central metal atom or central metal ion. Central metal atom or central metal ion. It is satisfied by neutral molecules or molecules as well as negative ions and also rarely cations also, means positive ions also. So the secondary valency is satisfied by neutral molecules, negative ions, and very rare cases it satisfied cations also. Cations means positive ions also. Okay, and it is fixed always. The secondary valence is fixed, and secondary valence is fixed, and it explains the geometry of the complex compound because the geometry of the complex compound depends on the coordination number. So the secondary valence is also equal to coordination number. It is also equal to coordination number, and it is fixed. That's why it explains the geometry of the complex compound. So the geometry of the complex compound depends on the spatial arrangements of secondary valencies. If the spatial arrangements of secondary valency is in tetrahedral, then the geometry of the complex is tetrahedral shape and coordination number is 4. If they are arranged in the octahedral manner, then the geometry of the complex is octahedral and coordination number is 6. That's why the secondary valency is fixed, non-ionizable. It is refers to the coordination number, and it explains the geometry of the complex compound. While drawing the structure of the complex compounds, the secondary valence is represented by thick bond or thick line. Okay, some of the complex compounds, some ions or molecules refers to the both are satisfied by the both primary and secondary valencies. Satisfied by the primary and secondary valencies. Those primary and secondary valencies, any molecule or ion satisfied both secondary and primary valencies represented by thick and dotted lines. So it is like this. If like this symbol is present, it indicates that the ions are satisfied by both primary as well as secondary valencies. Both primary as well as secondary valencies. Okay. So such ions are mostly present in the coordination sphere only. So these are the important postulates related to Werner's theory. So based on these postulates, Werner has explained coordination number 6 contains cobalt complexes, hexaamine cobalt 3 chloride complexes structures have explained perfectly. Okay. Now, but these postulates does not explain the all properties of complex compounds. So what are some limitations are present, some failures are present. What are the important failures of Werner's theory? So this Werner's has tried to explain the structure of the complex compounds, but that structure of the complex compounds in that central metal ion means how many molecules or how many atoms or ions bonded around the central metal ion. It does not relate to the electronic configuration of central metal atom. It does not related to the electronic configuration of central metal atom. And the second thing is it does not explain how the ligands are satisfying. Ligands means what, ma? This secondary valence is also the molecules or atoms or ions also we are calling as a ligands. So how the ligands are satisfying, some of the ligands are satisfying both primary and secondary valences. How they are satisfying, he does not explain. He does not explain. And one more thing is, he does not explain how the complex compounds are coordination compounds having color and shows magnetic properties and also shows optical properties, means optical isomerism. They exhibiting optical isomerism as well as geometrical isomerism. And another thing is structural isomerism also they are exhibiting. So how they are exhibiting isomerism and how they are exhibiting magnetic properties as well as color properties is does not explained. So those are all failures furtherly that explained by the VBT theory, valency bond theory, valency band theory, as well as crystal field crystal field theory, CFT, crystal field theory. So finally the crystal field theory successfully explained that all color properties and optical isomerism as well as magnetic properties and everything. Okay, so these are the some failures related to Werner's theory. So now we discuss about what are the important structures explained by the Werner. Let's see. Already I said Werner explained the structure of coordination number 6 containing cobalt, three complexes. Cobalt 3 complexes. Okay, let's see. The first one is CONH3. The first one is CONH3, CO6NH3, and Cl3. See, 6 ammonia molecules are present and 3 chloride ions are present. So he explained that structure, how that which acts as a secondary valency, which acts as a primary valency with coordination number 6. With coordination number 6. So further he has proposed this structure. Cobalt is around 6 thick bonds is see, secondary valence is satisfied by the neutral molecules and primary valence is satisfied by only negative ions. Only negative ions. What is this 3? Round number 3 means oxidation state or oxidation number of the central metal atom or central metal ion. See, it takes 6 ammonia molecules are surrounded by the cobalt. Okay, means all are in the secondary valency. Now, secondary valency 6 means the structure is a octahedral geometry. The structure is a octahedral geometry. Remaining 3 chloride ions acts as primary valence. So dotted lines. According to this structure, how to write the complex compound formula? Means generally I said for representing the formula of complex compounds, we must have to use square bracket. The square brackets contains central metal atom as well as ligands. So those all that completely is called as coordination sphere. Now in the coordination sphere, central metal atom is cobalt, is bonding with 6 ammonia molecules, and the remaining 3 chloride ions, negative ions mostly present on the right side of the coordination sphere, and positive ions are present outside the coordination sphere on the left side. Now Cl3 is present. This is the structure. Now this structure contains secondary valency is equal to 6 NH3. Primary valency is contains 3 chloride ions. Both primary and secondary valency is 0. Both primary and secondary valency is 0. Okay. Now this compound we are treating with excess of silver nitrate. Excess of silver nitrate, and forms how many number of chloride ions? Silver chloride ions. Means it forms 3 moles of AgCl PPT. Because the negative ions 3 are present, it combined with 3 moles of AgNO3 silver nitrate, then 3Ag plus 3Cl minus, then forms 3 moles of AgCl forms. And one more thing, in aqueous solution, how it will be ionized? In water, it will be ionized CO NH3 6 times 3 plus. What is the charge on the coordination sphere? Plus 3. So indicates that this complex is example for positive coordination compounds. If they are having negative charge, negative complex compounds are negative coordination compounds. There is no charge, then those are called neutral compounds. Okay? Plus 3Cl minus. Total how many ions are forming? 4 ions are forming. 4 ions. Okay? So this is the information related from this structure. So what is the geometry of this compound? Octahedral. Octahedral geometry. Okay, let's see one more structure. CO 5NH3 Cl3. See. Here the neutral molecules 5 only present, but the coordination number is 6. We need to arrange coordination number 6 means one chloride ion acts as both primary as well as a secondary valence. Now its structure. NH3 one chloride ion acts as both primary and secondary valence. The remaining two chloride ions acts as only primary valence. So secondary valency is equal to 5 NH3. Both primary and secondary valency is equal to 1 chloride ion. Only primary valency is equal to 2 chloride ions. So Now the ions which are accessed both primary and secondary is non-ionizable. It will be present on the coordination sphere only. According to that, what is the structure of this compound? CO NH3 5 times Cl. The formula we need to represent like this, and the remaining two chlorines in the outside is treated with excess of silver nitrate. Forms how many number of moles of silver chloride is forming? Is important mark for NEET and JEE examination. They will give this formula only directly: CONH3 5NH3 Cl3. Then it reacts with silver nitrate, forms how many moles of silver chloride? So two chlorine atoms are in the outside the coordination sphere, forms 2 moles of AgCl. If it is in water, ionized to how many ions? Forms how many number of ions? CO NH3 5 times Cl. What is the charge on the coordination sphere? 2 plus 2 Cl minus. See here number of ions for this compound CO and 6 NH3 Cl3. 4 ions are present in aqueous solutions. But now here only number of ions how many are present? 3 ions are present. So which having more number of ions in aqueous solution, it has molar conductivity is more. Our conductivity will be more. So CO6 NH3 Cl3 has more molar conductivity when compared with CO5 NH3 Cl3. That concept also very important. That also they are asking in NEET and JEE examination. Next, see that one more structure related to this. CO 4NH3 Cl3. In this case, 4 ammonia total molecules, they act as only secondary valency. But the coordination number must should be equal to 6. That's why 2 chloride ions acts as both primary as well as secondary valency. So the remaining 1 chloride ion acts as only primary valency. So secondary valency is satisfied by 4 NH3, and both primary and secondary valence is satisfied by 2 chloride ions. Only primary valence is satisfied by 1 chloride ion. Its geometry is octahedral geometry and hybridization is sp3d2 hybridization. sp3d2 hybridization and coordination number is 6. Now this molecule represented by CO NH3 4 times and Cl2. So 2 chloride ions are enters into the coordination sphere for satisfying its coordination number 6. And 1 chloride ion is outside. When it is treated with silver nitrate, excess, how many moles of silver chloride will form? 1 mole. 1 mole of silver chloride will form. In water, how it will be ionized? In water, it forms CONH3 4 times Cl2 plus Cl minus. So 2 ions will form. The number of ions is 2 in water. And one more structure. CO3NH3 Cl3. CO3NH3 Cl3. Now in this case, coordination number we need to exist 6. But here double molecules 3 only present, negative ions 3 also present. The 3 negative ions also we are considered. in coordination sphere, they access both primary and secondary valency according to Werner theory. Now NH3, first you write NH3 molecules, 3 over. The remaining 3 bonds, just to make it thick and dotted bonds, then you write chloride ions. So only primary valency is not present. So now, in this case, secondary valency is equal to 3 NH3, as well as primary and secondary is equal to 3 chloride ions, and the primary only is equal to 0. There is no ions present in primary valency or outside the coordination sphere. Now the complex formula we are writing as NH3 thrice and Cl3. It is a neutral complex compound, is treated with silver nitrate, no PPT. Means the number of moles of silver chloride is 0, and if it is in water, cannot ionize. Cannot ionizes. Is not ionizes means number of ions 0. Number of ions equal to 0. Its conductivity. Conductivity is 0. Means it is insulated. Electrically, conductivity is 0. Means it does not conduct electricity because there is no ions. The coordination sphere cannot be ionized in water. Only outside the coordination sphere, if any positive and negative ions are present, then can be ionized to give ions. But it is neutral. There is no ions it forms in water. So I explained 4 structures total. While I observed 4 structures, what are the 4 structures now? CONH3 6 times Cl3 and CONH3 5 times Cl and Cl2. CONH3 4 times Cl2 and Cl, and CONH3 thrice Cl3. Let's see 1, 2, 3 and 4. The coordination number is always 6, and here secondary valency is 6. And all cases, secondary valency is mainly represent the coordination number. So in all cases, secondary valency is 6 only. But here there is no ions present in both primary and secondary valency. But here one chloride ion accesses both primary and secondary valency. And here 2 chloride ions access both primary and secondary valency. And here 3 chloride ions access both primary and secondary valency. Okay. Now in water, number of ions in water in aqueous solutions. So it forms how many ions? 4. It forms how many ions? 3. It forms how many ions? 2. It forms 0. So conductivity order or molar conductivity order. Molar conductivity order, 1 is more than 2, and then 3, and then 4. Okay? So the first complex has more molar conductivity because it forms number of ions is more. If number of ions increases in aqueous solutions, molar conductivity will be increases. And the number of ions, number of silver chloride or number of moles of silver chloride forms. Number of moles of AgCl formed when treated with excess of silver nitrate. Excess of silver nitrate means it should be more. We are taking the limiting reagent is that complex compound. Means how many? This means less number of moles present. It is excess means how many chloride ions are present. That all chloride ions are completely react with silver nitrate. Then forms how many moles? 3 moles of AgCl. And here 2 moles of AgCl, silver chloride forms. And here 1 mole of AgCl forms. Here 0. The fourth compound is 0. 0 moles or does not form any silver chloride precipitate. So these are the important points related from those structures of coordination number 6 containing cobalt 3 complex compounds. Cobalt 3 complex compounds. But this name is hexaamine cobalt 3 chloride. But this name is pentaamine chloro cobalt 3 chloride. Because these all are positive complex compounds. Here, what is the charge on the coordination sphere? +3. What is the charge on the coordination sphere? +2. What is the charge on the coordination sphere? +1. Charge on the coordination sphere is 0. But what is the oxidation state of cobalt? Here, ammonia NH3 is a neutral ligand. That chloride ions are negative ligands. Now, what is the oxidation state on cobalt? +3. Generally, while writing the IUPAC name of complex compound, the oxidation state we are represented in Roman numbers. Okay, and all cases the oxidation state or charge on the central metal ion is +3 only. Charge on the central metal ion is +3. That's why cobalt 3 chloride compounds. Now this trichlorido cobalt 3 only, because there is no negative ions on the outside the coordination sphere. There is no anionic sphere as well as no cationic sphere. Okay, next. Let's see. Already last class only we have discussed the general representation of complex compounds or coordination compounds. So, according to the general representation, what are the important terms in complex compounds or coordination compounds? That also very, very important. Sometimes they are asking 2 marks questions from that important terms or important definitions. Okay, and for objective purpose also important, especially for ligands classification is important for objective. See, important terms in complex compounds. In complex compounds. Let's see what are the important terms in complex compounds. We know very well the general representation of complex compounds. The general representation of complex compounds, MLX plus or minus M. Last class only I explained it. The square bracket is completely the square bracket is called coordination sphere. Coordination sphere or coordination entity. This L represents ligands. This X represents how many number of ligands are bonded with central metal ion. It also represents that coordination number. Represents the coordination number. This is charged on the coordination sphere. Charge on the coordination sphere. This M is represents central metal atom or ion. Now, these all we need to discuss. What is central metal atom or ion? What is coordination entity? What are the ligands? What is coordination number? And what is the oxidation state of central metal atom or ion? So, we need to discuss one by one. Okay. Just listen. The first one is central metal atom or ion. What is central metal atom or ion? Central metal atom or ion is nothing but the metal atom. Central metal atom or ion is nothing but it is the transition metal atom only. The metal atom in which the metal atom in which the metal atom which is surrounded by molecules. Molecules are ions. Molecules are ions. Ions means negative ions or maybe positive ions. Generally, the molecules or ions are called as ligands. Surrounded by molecules or ions called as central metal atom or ion. Central metal atom or ion. Central metal atom or ion is nothing but it is the metal atom only one. It is the metal atom which is surrounded by, means around that metal atom contains molecules or maybe ions. Those are called central metal atom or ion. See, the second one is coordination entity. Coordination entity. Coordination entity is nothing but the coordination entity is nothing but central metal atom or ion is surrounded by fixed number of molecules or ions. The fixed number of molecules or ions is nothing but ligands only. Surrounded by fixed number of molecules or ions through coordinate covalent bond or day-to bond. Through day-to bond linkage known as coordination entity. Known as a coordination entity. See, for example, CO NH3 Cl3. In this coordination entity, central metal atom is cobalt, is surrounded by 3 ammonia and 3 chloride ions. So, in this coordination entity, central metal atom, Cm means central metal atom, is equal to cobalt, is surrounded by, is bonded with, how that bonds, coordination, covalent bonds or day-to bonds, bonded with 3 NH3 molecules and 3 Cl minus ions. 3 Cl minus ions. The same way we can write so many examples. Copper NH3 plus 2, or in which coordination entity, in this coordination entity, copper is the central metal atom, is bonded with 4 ammonia molecules, as well as nickel H2O 6 times plus 2. So on this coordination entity, charge is plus 2. Okay, on coordination sphere, so coordination entity is nothing but coordination sphere only. So in which the central metal atom or ion is nickel and is surrounded by 6 water molecules. 6 water molecules. That's why coordination entity is nothing but, so the coordination entity is nothing but a central metal atom which is surrounded by the fixed number of molecules or atoms or ions is known as, so that how they are bonding, present that fixed number of atoms or molecules or ions through a day-to bonds is known as a coordination entity. So indirectly, coordination entity is nothing but coordination sphere. In that coordination sphere, what are the present? Central metal atom as well as ligands are present. So the next we will discuss about ligands. So before discussing about the ligands, what is coordination number we will discuss. After that, ligands.